Now let us consider the pulley case. So in the pulley, we have connected mass m1, I have represented it by A, and m2 is here. So m1 is greater than m2. So if m1 is greater than m2, then the system will accelerate. So this mass will go down and this mass will go up. Because m1 is heavier, this will come down, this will go up. m2 will go up, m1 will come down. But the tension in the same string is same. So here also the tension acts away from the body in this direction, that is T. Here also the tension acts away from the body, that is equals to T. Also the acceleration is same. The whole system will move in same acceleration. But this m1 will have motion in downward direction. So acceleration will be in downward direction. So here m2 is moving upward. Because m1 is coming downward, m2 will move up. So m2 will have acceleration in upward direction. That we have to remember. If m1 is greater than m2, this is the case. Now let us draw the free body diagram. This is m1, this is m1. So T is acting upward, that is away from the body. So it is like this. m1g is acting downwards, that is due to gravity. Then acceleration is downward direction because it is accelerating downwards as m1 is greater. So now we have to write net force is equals to mass into acceleration. So what is the net force? m1g minus T. Because it is accelerating downwards, then definitely m1g must be greater. So m1g minus T equals to m1a. Let us see for this case, it is accelerating upward. So for that, for m2 to accelerate upward, then the case, so it is accelerating upward. So the upward force must be greater. So T minus m2g equals to m2a. So now, for finding acceleration, we are going to add these equations. So m1g minus T plus T minus m2g equals to m1a plus m2a. Now plus T minus T goes off. So m1 minus m2 into g by m1 plus m2 is equals to acceleration. So this is the expression for finding acceleration. Let us see how we are finding tension. Already we have written this case, m1g minus T equals to m1a. This equation I am rewriting it like this, T equals to m1g minus m1a. So m1g minus m1a I have already found, that is m1 minus m2g by m1 plus m2. Now m1g I am taking commonly out. So 1 minus m1 minus m2 by m1 plus m2. On simplifying this equation, we are getting T equals to 2 m1 m2 by m1 plus m2 into g. This is the expression for finding tension in this case. Let us see another case of pulley. So here there is a pulley over here at the corner and two masses m1 is like this, hanging vertically downwards, and m2 is placed on this platform. M2 is placed and the whole system is accelerating in this way. So m1 is going downwards, m2 is going this right side in a horizontal direction, m2 is going. Now we know how tension acts. For m1 it will be like this, for m2 it will be like this. For that particular body, the tension should be away from that body. That is the key point you have to remember. Now m1g is acting vertically downwards. m1 is accelerating in this way. Taking m2 will go right side and not up or down. It will go right side. So its acceleration is in right side. So m2g is acting vertically downwards and its reaction is acting vertically upwards. Let us see the free body diagrams. So for m2, this is this case. For m2, tension is acting right side this way, reaction upwards, m2g acting vertically downwards. So here in the direction of motion, that is acceleration is in this way. So in that direction, the only force is tension and not R or not m2g. These are normal to the motion, so we are not going to take any of those forces. So only force in the direction of motion is tension. So T equals to m2 into a, that is the net force is only tension, that is equals to that particular mass m2 into acceleration. Here the tension is same because the string is same. Again the whole system will have same acceleration only. m1 or m2 both will have same acceleration. For M2, for M1, what is the free body diagram? M1 is like this, M1G is acting vertically downwards, tension is acting upwards, and this M1 is accelerating downwards. So this is accelerating, this is the direction of acceleration. If this is the direction of acceleration, then definitely this force must be greater than tension. So M1G is greater than tension. So M1G minus T equals to M1 into A. This is the equation of motion. Net force is M1G minus T. That is equals to M1 into A. Because it is accelerating downwards, this force is greater, we can write. So M1G minus T equals to M1 into A. Now, M1G minus T equals to M1 into A. But T we have already seen, that is M2 into A. So M1G minus M2A equals to M1A. M1G, that is equals to M1A plus M2A. So acceleration is M1G by M1 plus M2. In this case, the value of acceleration is M1G by M1 plus M2. What about tension? Tension we have already seen from the free body diagram. It is just M2 into A. So T equals to M2. Acceleration is M1G by M1 plus M2. So this is the expression for finding tension.